So in the previous video we introduced Dropout, where we drop random nodes during training. However, how do we use Dropout during inference when we want to make predictions on new data? Let's talk about this in this video. So during training we randomly drop these nodes, but during inference, what do we do there? During inference we want actually deterministic behavior. We don't want to drop any nodes during inference. Otherwise what would happen is that we would get different results every time we use our neural network on new data, and that would be pretty confusing or annoying. So in simple terms, during inference we don't drop any nodes. However, there is a small adjustment that we have to make. So in order to explain the adjustment that we have to make, assume that we have a drop probability of 50%, which means we are dropping approximately half of the nodes during training. So during inference, if we then look at the node in the next layer, what will happen is that this node will receive twice as many inputs now compared to the training mode before. So in training, half of the nodes in the hidden layers are missing, and then during inference, the nodes in the next layers will receive twice as many inputs during inference. So consequently, if we assume for simplicity that the activations have a constant value, what will happen during inference is that the activations at the node in the next layer will be twice as large in inference mode if we don't make any scaling adjustments. So what we then do during training when we have a drop probability by 50% is that we are scaling these hidden layer activations by 1/2. Or in general terms, if we have a drop probability of p, during training we scale the hidden layer activations by 1/p. So for example, consider an activation of value 5 during training. If we then scale 5 by 1/2, what we have as the activation value is 10. So yeah, and that is how we use Dropout during inference. So during scaling, we typically just scale the activations so that the sum of the activations during training is equal to the sum of the activation values during inference. Alright, now that we talked about Dropout, how it works in training mode and inference mode, let's talk about how we use Dropout in PyTorch.